The Federal Aviation Administration, an agency within the Department of Transportation, is committed to the operational safety and efficiency of our national airspace system. In recent years, aviation has seen tremendous growth and increased operational complexity. Commercial aviation accounts for 8% of our gross domestic product and is expected to increase 50% by the year 2025. That is why the Next Generation Air Transportation System, or NextGen, our airspace modernization plan, was developed.
NextGen will transform our airspace from ground-based air traffic control to satellite-based air traffic management.
One element of NextGen is the optimization of airspace and procedures in the Metroplex, or OAPM project.
Metroplexes are geographic areas including one or more busy airports surrounded by complex airspace. OAPM is a design process that integrates performance-based navigation, or PBN, into selected metroplexes.
PBN allows aircraft to fly precise flight trajectories that increase efficiency, decrease fuel consumption, and reduce carbon footprints. OAPM will integrate PBN procedures with airspace modifications to maximize benefits in a metroplex. A great example of this is on a PBN optimized profile descent. An OPD can replace a traditional step-down approach, including several costly level-offs, with a more efficient descent profile.
They can start and let the airplane actually fly itself based on what it needs as far as engine performance, fuel. It allows that airplane to maximize or to optimize its track, its flight, and it flies the most efficient. It uses the right engine thrust, the least amount of fuel. It produces the least amount of noise.
Metroplexes were selected as candidates for participation in OAPM based on traffic levels, operation types, delays, and complexity. The first team, which was utilized as a prototype, examined the airspace around our nation's capital. Study team members took a first-hand look at airspace problems that plagued the Metroplex. Problems such as inefficient arrival and departure pads. Using local experts to help identify issues, the team created proposals that will result in fuel burn reductions, shorter routes, and reduced pilot-controller communications. OAPM includes participants from the FAA, the National Air Traffic Controllers Association, and industry stakeholders, all bringing collaborative expertise to the process.
Once a Metroplex is selected, a study team analyzes its airspace, exploring opportunities for improvement, and provides redesigned strategies.
The study teams make refinements that include converting conventional procedures to PBN, reducing or eliminating level-offs, segregating routes to deconflict traffic flows, expediting departures, and realigning airspace to support those changes.
Design and implementation teams execute the rest of the process, including conducting all appropriate operational, safety, and environmental analyses. OAPM will take a Metroplex from the study phase through implementation in approximately 3 years, much quicker than the current prescribed process. From international gateways to smaller general aviation airports, designs can include building in procedures and infrastructure that can increase access and will improve safety, which benefits the entire community.
The optimization of airspace and procedures as a result of Metroplex initiatives will help lay the foundation for next-gen operational capabilities and flexibilities that allow airports to maximize their infrastructure and operations through features like automated taxi and departure procedures, decreased delays, and minimized taxi and holding times.
The operational efficiencies of Metroplex airports are vital to local economies. Implementing next-gen technologies will increase the need for a highly skilled, well-paid workforce in many local areas. By utilizing performance-based navigation and a systems approach to our Metroplexes, the FAA is making air transportation safer, more efficient, more economical, and environmentally friendly for our future transportation needs.